All right, welcome back to another Zed Decoded. I'm joined today by Michaela, Kate, and Max. Hello, everybody. And these fine folks have all been working on Zed on Windows. And a common question we get asked is, Windows when? When is it going to be ready? When can we actually use it? So it's currently in alpha, meaning that you can use it. And we'll start off with a little demo of it. But it's not ready for stable yet because it's just not done yet. And we'll talk plenty about some of the challenges that we face along the way and the current status of things, like where they are, why some things have been maybe harder than they might seem, and also some specifics around the technical challenges and the technical status of where we are with those things. So why don't we start off with just a little demo. Max, I think you can do a little screen share and we can see where things are at the moment.
Yeah. So let's see. Is this showing up? So here's Zed on Windows.
Hey!
You can see, for the most part, it works. I've been using it every day for the past 6 weeks or so. We've got, let me give you a little, got language servers.
Get blame.
Yeah, git blame. Let me toggle that. But look at that blame featuring one particular contributor heavily. That's Junkui, who's our member of the Zed Windows team in Wuhan, China, who kind of started off the whole Windows port actually before as an open source contributor. What else can I show? Sort of Git panel. Well, I don't have any diff right now, but I can open Git commits. I can install extensions. So a lot of stuff working. Maybe we should go into what is not working.
Yeah, I figured we could maybe start with some really basic familiar challenges to people. So far we've had Zed on Mac OS and Linux, which are both Unix based operating systems. So they do the forward slashes and the paths, whereas Windows by convention does backslashes, although forward slashes are also supported. So why don't we just talk about some of the sort of challenges related to paths that we've encountered for the first time with Windows that we didn't have to deal with either Mac or Linux.
I think So a lot of times it just works because we're using Rust, and the Rust standard library sort of abstracts over paths. You can see it here in this in our breadcrumbs for this file. We have backslash delimited paths. One interesting thing that we can show that's not fully baked is that Git sort of, the way we're using Git, you see an odd mixture of forward slashes and backslashes in this path. So there is some differences in the way different tools on Windows treat paths that we still need to iron out. This obviously works, but is a little wonky. The biggest place where the path difference matters is where we're sort of at the intersection of two operating systems. So one of those is when you are remoting into a Linux box from Windows. That works right now, but there's some challenges with like kind of edge cases around Linux paths, but we do have to sort of explicitly kind of represent paths that are on a different operating system and that have different separators. Another place where it's a challenge that we still haven't solved is when it comes to extensions. Extensions in Zed. Here I can open up one of the extensions, the source code for it, like the HTML extension. Extensions have not entirely been adapted to work with Windows yet. They kind of are interesting because the extensions are packaged as WASM binaries. So it's the same compiled artifact that you run on all platforms, which for the most part works great because of WebAssembly, how WebAssembly is designed, but we have a lot of extensions have code that downloads a language server, checks that the language server is already installed, and so they have to do file system manipulation, and the same compiled code has to work on POSIX platforms like Mac OS and Linux, and Windows, and so there's some challenges here where we have to pass paths back and forth between the host, which is running Windows, and the extension, which is this sort of cross-platform binary that is not specifically compiled for Windows. So there's some things that don't work yet with that we need to iron out.
Gotcha. Have you run into any weirdness around, like, I know that there are some paths, path characters that Windows doesn't allow that Unix does. Like, so in Unix, my understanding is that paths are encoded in essentially UTF-8, except that the 0 byte is disallowed, whereas UTF-8 permits it, because they use those for null terminators. Whereas in Windows, it's UTF-16, and also there are some additional character ranges that are banned beyond just 0, which means you can have... These are weird edge cases that probably would never come up in Unix paths, but they could. And so have we run into anything around that, or has it kind of been smooth sailing?
I think we have not yet. I think we're at the stage where most paths work fine. There are probably edge cases that we haven't solved yet that are like a little further down the roadmap of attacking those edge cases. The ones that I know of is that, and this is actually there may be edge cases on other platforms that we don't handle as well. Sort of round paths are not, like you said, on Linux and Mac. Paths are basically, they can be any sequence of any bytes except for null, which includes some things that are actually not valid UTF-8.
True.
And those cases I don't think are handled correctly in all parts of the code base. There are certain parts of Zed that round trip paths to strings and back, around SSH remoting, collaboration, and those also persisting paths in SQLite. I think we do some of that as well. And I think there's kind of the same. There are different characters that would break on Windows and Linux. On Windows, we've got, paths are sort of also not guaranteed to be valid strings, but they're the sequences of U16s. So that they're pretty rare edge cases, though, from what I understand. So it's sort of not something we've hit yet, and we have a little bit bigger fish to fry so far than that. But I think we'll get to it.
Yeah. Yeah, something I find interesting about Windows paths in particular is that it's sometimes hard to describe like what a canonical Windows path is, because you obviously have like normal paths, right? But if you want more than like 260 or something characters, then you need to do this other format, right? Which is like UNC paths or whatever. And like, Git has settings that will make it use those paths internally, right? But then there's just even other weirdnesses, like Windows is just fine with forward slashes. Like most of the Windows APIs will just work just fine if you pass forward slashes instead of backslashes in the past, right? And so at some point there's handling that all and making that all work and look correctly. And then there's also like, what does correct even look like for, like, it's very, very contextual on Windows in a way it isn't quite as much on Linux and Mac OS.
Right.
Got it. Okay. Well, so that's kind of a nice warm up, and that's file paths are maybe one of the more easy to understand, reasons why things might be different. So let's move on to something that's a deeper rabbit hole, which is graphics. So, if we were just doing an Electron fork, which we extremely are not with Zed, then we'd be like, oh, browsers figured that out, and we're just wrapping a browser. But we're not wrapping a browser. We do all of our own graphics, going straight to the OS level GPU rendering stuff. So let's talk about that a little bit. What has been different about dealing with graphics on Windows compared to dealing with graphics on Linux and Mac OS?
Well, we started out when porting to Windows using the same renderer that we were using on Linux, which is based on Vulkan. It's using this library called Blade, but it's a Vulkan renderer. And that did work, but we sort of hit some issues that we concluded would be more straightforward to solve fully if we just had a dedicated Windows renderer based on DirectX. And so Chukui led this effort to kind of create a third graphics backend for Zed. We already had a Metal one for macOS and a Vulkan one for Linux, and so now we have this DirectX renderer as well. And so there's a whole layer of the code that is distinct on Windows, that sort of around. I guess maybe the best thing to show would be the this draw. There's a small set of graphics primitives that we support in our UI framework, GPUI. So it's not like a huge project to create a new graphics backend, but it is. There's like, you can kind of enumerate all the things that we have to be able to draw. We've got shadows, quads, paths, which are sort of arbitrary curves and lines, underlines, monochrome sprites, which are the way that we render font glyphs, polychrome sprites, so that's like sort of images, and that's it. So we sort of had to develop new rendering routines for all those things using DirectX and instead of Vulkan.
Does that involve rewriting shaders, or?
Sure does, yeah. So kind of here's the shader, the HLSL file that's our shaders for Windows now. And so these are all, all the shading languages are pretty similar, but a little different. And so our strategy thus far has been to have, not to use any kind of like abstraction layer that kind of wraps all the shader languages on different platforms, but to just have a dedicated implementation for each platform. So we have 3 of these sort of roughly 1,000 line shader files, one for each platform. And yeah, I guess that kind of the process of developing this led us to, there was some work to do to be able to debug this. Like basically like the to be able to debug shaders, sort of it's different than debugging code that runs on the CPU, and so we wanted to be able to use this program RenderDoc, which is sort of a graphics pipeline debugger, and there were sort of some interesting challenges there. But maybe Kate, do you want to explain like what our journey with that?
So this is also related to what you're always seeing on screen is the fonts that the app renders. On macOS and Linux, we have nice ways of rasterizing those fonts. And they are nice because they look correct for the system and they do not interfere with you debugging stuff. Debugging on the GPU happens with an external program because GPUs are built way different from the CPU side. And we initially tried using Windows APIs for font rasterization, how they are recommended to be used, which is the direct-to-D way. But that unfortunately interfered with us debugging, as that uses undocumented internal calls, which break every introspection layer that RenderDoc, Nsight, or other tools use. Because the way those tools allow you to debug your shaders is they intercept every call that you make to the GPU and interpret it their own way to display it to you. Because DirectD was doing internal undocumented calls, the introspection layer didn't know what to do and was crashing. This appears to be the case on every single frame debugger that is present, even on the official release for Windows, so official by Microsoft, which is unfortunate. So we had to also rewrite our whole font rendering to do it in a custom way that we did, which allows us to now finally debug shaders on Windows, and we can actually solve issues that we see. And as another benefit of that is our font rendering can be more customizable, because everyone has different opinions on what fonts should look like, so you can't always satisfy everyone, but we try to make it look as good as possible. And on Windows especially, it's challenging, because on Macs, you always know you're going to have a really high quality display. However, on Windows, that is not the case, because some people have low DPI displays, some people have high DPI displays, and this is a tricky challenge to solve to render correctly. And as another point to us cutting out the native API, we had to make our own emoji rendering completely, as there is no pre-made one, and that is a really interesting challenge. Basically, how you get the emojis, like a series of color layers, and you have to composite them So for that, our DirectX backend actually came quite nicely because our Vulkan and Metal backends don't really support anything besides our basic primitives, as Max said. So we can't really do anything custom there. But because we use the DirectX backend is written specifically for Windows, we can add a specific feature there to allow us to composite the glyphs directly. So all the emoji compositing happens on the GPU, which will really help with rasterizing them quickly.
Yeah, so
nice.
you wrote this custom shader to rasterize to composite emojis. It's pretty cool.
Kate, you also mentioned towards the beginning of your explanation of how, like on Mac OS and Linux, you sort of have like built-in obvious choices for rasterization, whereas on Windows it's not the case. Do you want to go into a little bit more detail on that?
Yeah, so on Mac you have the core graphics or core font, something like that, that is really nice. On Linux there isn't a built-in way, but we use Cosmic Font, which seems to work pretty nicely, and it uses the standard GPU APIs. On Windows we have DirectWrite, which is supposed to solve the same issue, be as good as it is on Mac. But the way Microsoft recommend using it is using it with Direct2D. That breaks every introspection layer, as the undocumented calls. So instead, the way we use DirectWrite is we ask it for basically an alpha texture, not the full rasterized glyph, but we ask it for the alpha part of it, as in where it should be rasterized, but not how it should actually be blended onto the screen. And this will produce you the same result for the fonts, but it will not give you the same result for emojis, as it gives you a black and white alpha texture. So for emojis, you have to enumerate every layer of the emoji, and every layer basically has this alpha texture and the color the layer should be, and then composite each layer on top of another in the sequence that they are given to you.
Gotcha. So theoretically, we could use DirectWrite for the entire process and say, like, don't just give me the alpha, but give me do all the compositing and of all the layers. But then if anything goes wrong, we have no idea how to fix it because we have no introspection whatsoever into that whole process. It's just kind of poking around in the dark.
Yeah.
Yeah, we considered just sticking with using Direct2D. There was no problem with it other than that it broke graphics debugging, but it just seemed like a bad position to be in to not be able to boot up the app under RenderDoc. So we sort of decided to make it a hard requirement that we would basically make it so that you could always debug Zed without having to change the source code with RenderDoc. And that's been helpful. We sort of had a few graphics challenges that we needed to debug, and that so having that has been important.
This also helped find us an issue on every platform that we had Zed on. It was previously not caught by anything, but when we were drawing underlines, you could see that on some displays they looked more wavy than on others, as in like the width of the underline was different. This was first caused by us doing it to like display independent, so we were doing it in pixel instead of device independent coordinates. And second, we were incorrectly passing the underline structure from the CPU to the shader. The CPU was only sending a byte at the end of the structure, but the GPU was expecting an integer, like a 32-bit one. It was a miracle the underlines worked at all. I guess structural alignment saved us on that, but this helped us debug the issue, and it fixed it on all three platforms.
Nice. Love it when that happens. Speaking of cross-platform, so you mentioned earlier that Max did that we are intentionally not using an abstraction over all the different shader languages. So you said like Mac OS and Linux and, or I guess Vulkan and whatever Mac OS calls theirs and
Metal.
Windows. Yeah, Metal and DirectX, they all use slightly different shader languages. And you said we intentionally chose to rewrite our shaders each time rather than using an abstraction layer. Now, of course, a lot of programmers hear that and they think, of course you would abstract over those. How could you possibly conclude that not sharing code between those is correct? Obviously, that occurred to us, but maybe we should talk a little bit about the trade-offs there and why we decided to go the way we did.
I don't know that the trade-off we chose will always be the right one. We started Zed with just a Mac OS implementation that coded directly to the Metal and Mac OS APIs, and it just, for us, I just think with the way the ecosystem is right now, I don't think there's I don't think there's an alternative that gives us as much control, I guess I would say. Like the great thing about what we're doing now is if there's a problem, say in our Mac OS layer, we're just, we're coding directly to the Metal API as documented by Apple. There's no sort of other layer that the problem, other like library that wraps Metal that might have the bug. We're just sort of, it's a very stock, straightforward Metal application. And so if there's a bug, it means we're using Metal wrong. And similarly with Vulkan and DirectX. There are these like tools now that abstract over all the different rendering APIs, like the web GPU libraries. Like on C++ there's Dawn, and on Rust there's WGPU. And I think at various points we've considered using those, but for us, like I guess I don't think that we have enough primitive graphics related code that it's a huge lift for us to maintain these three backends, and what we get out of it is sort of this assurance that we have control, I guess. And maybe at some point it'll be the case that the wrapper libraries are mature enough that we can 100% depend on it being as fast and as bug free as if we coded directly to the platforms. But our priority is kind of having control. It's sort of been a lot of aspects of Zed are that way. We've decided to build stuff ourselves, and I just think it works for our team to operate that way, to not be sort of at the behest of any other kind of abstraction that we kind of don't fully understand.
For something so critical, and like you said, the number of primitives that we need to implement shaders for is quite small, so it's not like we're talking about a gigantic chunk of code. Okay, before we move on from graphics, let's just talk a little bit about sort of like what's left to do there before we're comfortable, putting this on stable. Because we talked about with the file paths, it's like, okay, a lot of stuff works, but also there are some edge cases that we know about that we haven't fully addressed yet, like with the extensions and WASI and all that. How about for graphics? Like, what's still kind of missing that we know about that we need to address before we feel comfortable with graphics on stable?
I think there's still going to be some tweaks to our glyph rasterization, as particularly on low DPI displays. There's sort of, I think it's TBD exactly how far we'll go with this, but unlike on Mac OS, it is common on Windows to use subpixel anti-aliasing to make text appear nicer on a low DPI display. Apple kind of did away with that, and so it made our job easier that we didn't. On Mac OS, we don't. There's no expectation that we would do that, but on Windows there is, and so there's. I don't know, Kate, you might be the best person to speak to, like, what is the state of our Zed on low DPI displays?
This also touches the directly move away. Since we were on that, we couldn't really affect any parts of the rendering. We were just like, this either looks like that or it doesn't look at all, like it's gonna be nothing. But now we have control over this process, and I feel like we could make it a lot better. The version you're seeing now is the best we have currently, but there is an improvement to be made because there are displays with even lower DPIs. Windows usually expects you to use subpixel anti-aliasing, as that looks better on displays with lower DPIs. Which is why some Linux distributions can look weird on displays, as they are usually using grayscale, specifically on Wayland. That's like a side tangent. We do not support that, and it might not be necessary if you're doing grayscale in a way that accounts for human perception, because our eyes also lie to us, and we have to account for that, because light text on dark backgrounds will seem thicker, and dark text on light backgrounds will seem thinner. So we have to kind of do gamma correction and contrast, which is, I think, what we're working on right now. And after that, I feel like we're going to be we can pretty confidently say the font rendering is good enough.
Nice. Now, is that also a case where we might see some benefits to Linux users after we've done this on Windows? Because like you said, there's Linux, is another scenario where you have low DPI displays. And I remember we had an issue, I'm not sure what the current status of it is, where people on Linux had been talking about encountering the same thing, where the font rendering looks good on a high DPI display, but not on a low DPI display.
Yeah, Linux could definitely benefit from those changes if we decide to merge them into there. We should also see how like beneficial they are for that platform. But I think because the platforms share such a similar way of rendering, it could definitely benefit.
Yeah, it's like even if the code needs to be repeated for Linux, our understanding and our approach we could potentially like reuse the same approach.
Nice. All right, well, let's move on from graphics. I know another issue where another area where you might not be expecting to find a problem is keyboard bindings. Now, I know that Mac and Windows and Linux have different keyboard layouts, but I would assume the main thing would be sort of command versus control. Like naively, I would think like, well, on Windows and Linux, they use Control+C for copy, and on Mac, it's Command+C. So once you figure the control thing out, which we already did for Linux, surely you're all set for Windows. Turns out, not so much. Should we talk about some of the edge cases we ran into there?
Yeah, I mean, I'll just start it off by saying, for me, the biggest adjustment in becoming a Windows developer in order to work on this project has been I'm pretty lost with the keyboard layout, and not having a command key is tough. You just have fewer modifiers to work with, assuming because we don't really want to use the Windows key in our key map, and so we just have Control and Alt, and so everything's different. I've kind of taken up Vim, using Vim, because there's just, if you don't use Vim, I just find there's not enough keyboard shortcuts. But yeah, like a couple things on my mind with keyboard shortcuts is also different expectations on Windows about how keyboard shortcuts show up. So one thing we recently had to fix for was so maybe someone can jump in here. My understanding is basically if you have a keyboard shortcut like Control-Shift-4, for instance. I think that's it. We have that. Let me see if I can find that in our key map. On Mac OS, the sort of platform convention is that would be displayed as Command $sign on a US keyboard layout, because when you hold down Shift and type a 4, you get a $sign. But on forget what instances of that we have in our key map. It's but like on Windows, that is not the way users expect the key binding to be displayed. They expect to see Command, Shift, and 4, the unshifted key. And so there was sort of a whole change we had to make to the way that we load these key map JSON files to sort of account for the fact that like when you have a binding that is like Shift and then a character, on Mac OS we want to display the shifted character to the user, and on Windows we need to display Shift and the unshifted character. That's just one odd detail of key bindings. What else? It's also the case that we just had a lot of bindings that we ported over from Linux that used Control and Alt. Kate, you want to explain that whole
yeah,
thing?
So on Windows, for English layouts, this causes zero problems, but there are layouts such as German or Czech layouts that use Control and Alt for typing other keys, as basically the base layout doesn't have the closing bracket on the German layout, so you have to use the Alt-GR +9 key or Control and right Alt to type that key, and that doesn't make a distinction between left and right Alt, and even if it did, it would not help us because some people use both ways of typing, and it would still conflict with their shortcuts. So the solution to that is just to not have Control-Alt key bindings, as that is the only reliable way we can ensure that we will not conflict with other layouts, as some layouts have one set of keys under Alt-GR, some layouts have different sets of keys, so even if we removed some, it wouldn't necessarily fix everything.
But then, of course, that's a perfectly reasonable key binding to use on Mac OS and Linux, so this has to be a Windows-specific rule.
Yeah, and this was something from the my work during the Linux port, but even that basic rule of, swap command for control, doesn't end up working out in a lot of cases because macOS, a bunch of the default text input and key bindings are also they've imported a bunch of the Emacs key bindings into native macOS stuff, and a lot of the switching command to control conflicts with that. But then there's even other problems where I think it was like tab selection or something like that. You have to change it's not just command to control, it's like command to alt or something like that.
Well,
there's just so many tiny little details of like the ergonomics of how your fingers move around that I would have loved to have an automatic keyboard key map translator, but you really just gotta make a custom one for each platform.
and sometimes there's an overloading problem where, like, on Mac OS, you have command left is like goes to the beginning of the line, and you have control left, which goes back a word. But of course, if you don't have command, then it's like control left can only do one or the other, or a third thing. It can't possibly cover both of those with one key combination. So at that point, you have to introduce either multiple key, like modifier keys, or only support one of the operations or something like that.
Or you just have to use
really
Vim.
Interesting.
Sorry.
Yeah.
Or just use Vim. Well, fortunately, we have, in my opinion, the best Vim experience in the entire world outside of like literal Vim. So
even with Vim, I'm going to claim ours is better because the multi-cursor support is awesome. But,
that's a great point.
Yeah.
Back when I was a Vim user, I would use multi-cursor plugins, and they were never as good as the experience I have in Zed, using Zed's built-in Vim integration, which is not from an extension, and multi-cursor, which is also native. So, fair enough.
Yet another key map thing is that sort of on different keyboard layouts, there's also different expectations about how bindings are adjusted, because often on some keyboard layouts where sort of certain bindings won't be possible, like bindings that involve the sort of keys like left and right square bracket might not be typable, or on depending on what keyboard layout you're in. So there's sort of this other layer of indirection that on Windows is called virtual key codes. And so there's this sort of whole other concept beyond sort of logical keys and kind of hardware keys that is this virtual key that we sort of use to kind of automatically map key bindings to an logically equivalent key for binding purposes for the current keyboard layout. And that's another layer that is kind of, we have on Windows, we have something completely different that does a related job on Mac OS. And we actually don't have that on Linux right now. So that's my understanding anyway.
Yeah, I don't know if we have anything on Linux, but I know on Mac OS, Apple, like we manually shift around certain key bindings. So you have things square brackets on the US keyboard are right next to each other, right? So those get remapped to a different location. So they're still next to each other and they still have that ergonomics, but it's just different. And there's just like a table somewhere in Zed that kind of re-implements this feature that macOS has.
Nice. Well, so what's left to do on keyboard shortcuts and things like that? I mean, are we at feature parity with Mac and Linux already, or is there still some room left for improvement before this is ready for stable?
I think we're pretty close on keyboard stuff. Kate, do you know if there's still major to-dos with keyboard shortcuts? Let me bring up our kind of master checklist. We had a whole key binding section that is, some of these things are still marked as in progress, but I think a lot of the stuff, if it's not done, is like their open PRs for.
By the way, for those who don't work at Zed, this is how we do all of our like issue tracking and to-dos. Is we have like just a markdown document in Zed in the channel notes, which you can go take a look at if you're curious in Zed. we're very lightweight. We work hard and we work smart, but we do not use bureaucratic tools. We just keep it very lightweight. Write it down and make it easily accessible to everyone. That's it.
Right. This is our Jira or Linear or whatever. It's just this markdown file.
It's
cool
slightly
because
more lightweight than Jira.
Yeah. We tried Linear. We tried GitHub projects. This is the only thing we've stuck to so far.
It's pretty great.
What's cool is that we just very often want to rewrite the roadmap. Say, okay, things have changed. We have a different set of priorities, and it's rather than like having to individually do a bunch of CRUD operations on a website to delete issue. It's like we can just collaboratively recreate it as text.
Right, and when we are working on the roadmap, it's like you'll see a bunch of cursors in here because there's a bunch of people in Zed, editing it collaboratively, in real time. That's how we do it.
That's how we do it. So yeah, I would say the key bindings thing, we were almost ready to move on from that. There's a bunch of things that are nearly done here. And yeah, there's a lot to do, but I think two of the big areas are remote development and WSL, which we kind of lumped together, and extensions. There's some missing features there. Maybe we could talk about remote development, because that is also very different on Windows.
Yeah.
So it's sort of like we touched on it about how when you're doing remote development, you've got a different path separator convention on the host that you're developing on versus your client machine. That's an issue. It's also another issue is that SSH just works very differently on Windows. So there's sort of a different SSH binary that is pre-installed that we're coding against. That's not the kind of typical like OpenSSL interface with SSH binary, and so there's different features. For our remote development support on macOS and Linux, we're pretty reliant on this feature of SSH called, I forget what the name of the feature is. It's called like, I'll just go to it. There's sort of this idea of like reusing a single SSH connection for many. It's called a control master, and it's sort of lets you open up one SSH tunnel and then leave it running and there's sort of a socket file that it kind of listens on, and then you can do many other SSH and SCP and sort of SSH-based commands that all go through that same connection, SSH connection. And Windows doesn't have that, and so there's sort of a number of features right now that don't work as well on Windows with remote development, where you'd sort of I think the current status is they would sort of work, although there's a little bit of less efficiency because you're not reusing the connection. And if you're using password auth, you'd have to repeatedly auth, which is, we can't ship with that. And so there's sort of Windows has its own completely different way of reusing SSH connections for between different SSH operations using something called a SOX proxy, a different mechanism of connection reuse. So we have to that's a big thing we need to do in addition to the path separator stuff. You can also see my current branch up here, WSL support. We're adding support for WSL. Very cool Windows feature where you can kind of got basically like a Linux container type thing running natively on your OS, and so we need to support that. We've heard from a lot of...
Good news, we already run on Linux, so there shouldn't be any work to do there.
Right, yeah. There shouldn't, but there is.
Yeah, which I guess is kind of a recurring theme here, right? It's like you might think that there wouldn't be that much involved in there, but once you actually dig into it, it turns out that it's like, well, in some cases the conventions are different, like the / backslash in the paths, and then sometimes the APIs are different, like you have DirectX versus Vulkan versus Metal, and then of course also you just have some things where it's like this is just a little bit weird. And we just need to do something a little bit different because of some combination of the way things are different.
Yep. A lot of little things.
Nice. Well, yeah, putting all this together, I mean, it sounds like, if I could summarize everything we talked about, it sounds like we've made a lot of really great progress on a lot of things. We've solved a lot of problems already. It sounds like we don't have any scary problems left. The problems that are left are sort of like known, and we can wrap our heads around them, but they still need some more work, which is why we're in alpha and people are able to try it out right now. Does that sound like a fair summary of where things are right now?
I think so, yeah. We get a lot of feedback from users that say, I use this every day, this is fine. But then there's other users who say, if you use WSL, which I can see why a lot of Windows developers do, you can't. we don't support that. Or a lot of little rough edges with paths, extensions, Git, different points of integration between us and the OS.
So it sounds like the direct answer to the original question of Windows when is not tomorrow, but pretty soon at this point.
Pretty soon.
So if people want to get involved in the alpha, or maybe try it out, obviously you can build it from source because it's all open source. But if somebody doesn't want to build from source, they want to get in on the alpha builds, where should they go?
We've got this really cool website called windowswhen.com.
It's really worth a visit.
I'm not going to show it.
Interested in Windows,
Yeah,
so don't want to spoil it.
Yeah, very good, useful website.
Yeah, and you can sign up to get on the list there.
We're going to ship it when it's ready. We're getting feedback. We're responding to the feedback. We know it's important. There's us. There's more other Zed developers are now using Windows, dogfooding it. As an organization, we're feeling the Windows.
Nice. Well, hey, it's very exciting to hear all the progress and also to understand the challenges better. So, thanks everybody so much for working on Windows and also for taking the time to chat about it.
Thanks so much, Richard.
All right, Windows
talking to you, Richard.
soon.
All right.
Yeah.
See you. Bye.
Bye, everybody.